So, the graph of this function I'm giving you here is a surface in three-dimensional space. Okay? It can be, you don't have to represent three-dimensional space in terms of x, y, and z. It could be r theta and phi, or r theta and z, different coordinate systems. So when I say x, y, z space, that's not really even a well-defined term, but it's in three-dimensional space represented on an x, y, z coordinate system. Okay? Then the graph intersects the plane C equals C, and this is a plane because you've got your x, your y, and your z. If z is C, which is a constant, then it's all the points where z equals C, which is all the points parallel to the xy plane, but up here where z equals C. Or maybe C is negative, so it'd be down here, below the xy plane. Okay? So we could actually depict that plane if here's x, y, z, and here's your value of C, then you can kind of sketch an indication of this plane just by drawing a straight line here, a segment here, and then expanding this to represent a rectangular section of the plane, and then drawing some horizontal lines this way and some lines parallel to the x-axis this way, and you can kind of see this plane floating above the xy plane. Does that make sense? Does the picture make sense to your eye?
Yeah.
Understand how I drew it? Practice drawing it. Okay? The lines want to run parallel to the x-axis, whichever way you decide to orient that, and parallel to the y-axis. And you want to have something up here then. Well, this represents a rectangle because this side is parallel to the x-axis, which is at 90 degrees with this side because this side is parallel to the y-axis. Okay? So there's a typical plane z equals C. Okay? So I'll say the graph of f of x, y intersects the plane z equals C. Well, since this graph is defined to be the set of points where z equals 4x squared plus 9y squared, so z equals C and z equals this, we get 4x squared plus 9y squared equals C, right? Okay? Make sense? Now what shape is this?
Just like a square, or is it?
Well, if you divide by C, you get a 1 over here, right? On this side, if you divide both sides by C, you get 1 here. Okay? And that gives you the equation of an ellipse, like we talked about last time. Okay? So let's just do an example. Take an easy number for C, okay? So if C is 36, we get this. Okay? If we divide both sides by 36, we get x squared over 9 plus y squared over 4 equals 1. And this is an ellipse with the semi-major axis 3, semi-minor axis 2. Okay? So just make that really explicit. This is x squared over 3 squared plus y squared over 2 squared equals 1. Okay? This is identified as an ellipse by the stuff I wrote out last time, right? So we can sketch this ellipse in an xy plane. Now this is not the xy plane of this graph, because this is what it's going to look like in the z equals 36 plane. So if this distance here is 36, then this plane is the plane z equals 36, right? Okay? And our graph within that plane is going to look like this, centered at the origin, so it'll be centered on the z-axis. Because the z-axis where both x and y are 0, right? That'll correspond to the origin of this picture. Okay? And how do we draw this now? We go 3 units in this direction, and 3 units in this direction, 2 units in this direction, 2 units in this direction. Now I didn't actually do the labeling of the axes, but you know from the picture that I drew last time, which was 3 units in this direction, 2 units in this direction, or it's x squared over a squared plus y squared over b squared equals 1, a units in the x direction, b units in the y direction, okay? So this gives you an ellipse, and you fit this ellipse in here so that it's nice and symmetric. Not that I'm going to be successful in drawing it that way, but it's going to look something like this. Okay? Now, sketch me the ellipse for C equals 144. Okay? So work that out very similarly and see what you get.